All right, here we are with the Law of Reflection Lab. Before you get started with this, you will need to make sure you have your lab packet, a straight edge, a protractor, and you may certainly use the straight edge of the protractor as a straight edge. I would recommend against using the curved edge of the protractor as a straight edge because it's not straight. You will also need the basic optic light source and the plane mirror and the cylindrical mirror for that part. So for part one, I'm going to take the direction sheet, set it off to the side. So traditionally, when we have ray diagrams with mirrors, we put the mirror on the right side. So I would set this up like this, more or less. Now, you notice that line there? That is the reflective surface, so that's actually going to go, if you can see it there, that reflective surface, the very back of the mirror, is what goes on the edge. I know it doesn't look like it with the shaded area there, but that's what it is. Now, the trick for making this work here is pretty straightforward. You just have to make sure that your mirror edge is really actually lined up with that black line. Now, from there, and if you need to move the paper, do it really gently, otherwise the mirror and the block will slide around. There's a very low coefficient of friction for those of you who remember that from back in the day. So I'm going to just rotate this a little bit so you can see better. The idea is I'm just going to shine the ray from the balls here, the basic optic light system. It's a mouthful, so I shorten it to balls, B-O-L-S. I'm just going to shine the ray from the balls down along this line, which in principle is at a defined angle that we'll measure in a couple minutes here. And this is wobbly because I'm a little bit off. Like so. All right, now that's a bit better. And you can see I'm just nudging it around. It's a technical word. Until the black line is really pretty much in the middle of the ray of light all the way down to the mirror. It's a little towards this near edge here, so I'm just going to turn the light a little bit so it's a little bit more in the middle, and there we go. So now it's just set up to make our measurement. If we zoom in a little bit, oops. Zoom in a little bit, okay, you can see the reflected ray of light. Now that's the one I'm interested in. Now this second part is really, really simple. All we do is we take a straight edge and line it up with the ray of light. Now you see here, this protractor, this edge is going to bump into the mirror. So rather than do it that way, I'm just going to turn this around. And again, now I'm not looking in the mirror, even though you can see in the mirror the image of the protractor is lined up with the image of the reflected ray. What you're seeing here, where the pencil is pointing, is not the reflected ray. The reflected ray is here on the paper. What you're seeing in the mirror is the image of the light that's bouncing off the paper here back to the mirror and then up to the camera. So when you're looking in the mirror, you're seeing an image, and that's not what we're interested in. Right now we're interested in the actual reflected light, which is a light that's coming off the mirror along the paper. Now this is a little bit of an iffy thing here, because this, as the ray gets further and further from its source, it's expanding a little bit. Not very much, but it is expanding. So this is actually a little bit more of a wide angle than it is down here. So we kind of put it in the middle, which is why I tried to get the black line here in the middle. And now I'm just going to trace this along with my pencil. Now before I move the mirror or anything, I'm going to just gently move my protractor away. And you can see the black line is directly on the reflected ray of light. Oh no, the stand is shaking. Get motion sickness. We don't want that. So we're going to zoom out. Turn a little bit here. So to do the next one, you basically do the same thing, just move the mirror to the right place. Again, we're lining up the back edge with the line and just do pretty much exactly the same thing. Line up the light, take your straight edge, line it up with the light that's on the paper, and trace it with a pencil. Once you've done that, you can move on to this next one. Okay, so if you've done the second one, same thing for the third. Again, trace the reflected ray. Now, once we've got that, you've got your marks on each one. And now the analysis is very straightforward. What we're going to do, we're going to take our straight edge again. I like the protractor because it's just a little handier. I'm not sure if it's a left hand or a right hand, but either way. And I'm just putting my pencil basically right on the line, aligning my protractor edge so that I can trace directly over that original line and then just extend it until it hits the normal. Now you can see we're a little off here. That's fine. This is not precision work, but just do the best you can. Now, this next bit, if you don't remember how to use a protractor, I shall attempt to remind you here. So we're going to get this nice and lined up. Zoom in a little bit at least. Now, to use the protractor, the important thing is you need one of the two lines of the angle. You can choose the dashed one, which is the normal or perpendicular to the surface. And if you do that, your crosshairs right here go on the vertex of the angle. This dashed line, if that's the one you choose, should line up from the crosshair directly onto 0 degrees on the protractor. So there's the vertex, and I'm going to have to look straight down to avoid parallax. And right about there, that's about as good as I'm going to get. Again, you have to look straight down. Since the camera is at a little bit of an angle, you might be able to see the dashed line below the crosshairs. So when you're actually doing this in person, you're going to look straight down on it. Now, and if you only hold it with one finger, it'll rotate and turn. So be careful. Hold it with 2 fingers. Now, again, 2 fingers when I move this hand. So reading it, we start, this is 0, so 0, 10, 20, 30, 40, something. And if I read this, again, I'm looking straight down. This is actually between, that's 1, 2, 3. It's between the 3, the 43, and the 45. So you can't see it because it's directly over the pencil mark, but there's a mark there for 44 degrees. So I'm going to write this angle as 44.0 degrees. If I measure this angle, the vertex is shifted a little bit over here. Okay. Again, looking straight down to line this dashed line up with the 0 mark. The 90 degrees should line up here because this is a right angle. That's what defines this dashed line. It's 90 degrees from the surface. Now in here, you can see pretty clearly that the line is pretty much directly under the mark right here. So again, here's 0, so 10, 20, 30, 40, 45. Now again, depending on how, if you're looking at it from a lower angle, you're going to get parallax error. So you want to look straight down, and then this is just going to be 45. Okay. Now, the law of reflection, if you look at the hypothesis, says that these two angles should be equal. And 45 and 44 obviously are close. They're 1 degree apart, but they're not equal. The second page is much like the first, except obviously here we have the mirrors, and it shows you where to put the mirror, so you're just going to line the mirror up. Now, these mirrors are not going to exactly match these curves. They've been squished and stretched over the years, so they're no longer perfectly cylindrical. So what you want to do is, the most important point to line up is the point where the ray of light is going to strike the mirror. So we want to make sure that this is best lined up right here at that point. And again, we want to make sure the reflecting surface is what intersects the ray of light there. And in this case, because this is a metal mirror, not a glass mirror, we're going to put the front edge right up against the glass. Now, if you look here, you can see the light, you can see the image of the ray. Now, that's not the path of the reflected light, that's the image of this. It's a little different there. I'm not going to worry about it. Now, again, like before, we just take the balls here and just line it up so that the ray of light goes directly over that arrow, and then use your straight edge whichever one you prefer. And you can see here I've using a ruler, line it up. You have to kind of be careful not to block the ray of light, so you're going to have to be a little bit offset from the mirror there. And we're just making sure as best we can that we're going to put our pencil in the middle of the ray of light. So if you're not sure, you can put your pencil down first, right in the middle.
Oh my God.
And then bring the straight edge in, like so, and then make your mark. And you can check, does the mark match the ray of light? And in this case, it's actually not so much. It's a little off. So what do? Well, if it's not obvious, we're just going to erase that line and try again. Here we are. I've reset. And you can see the old line is kind of faintly visible. If it's really bad, you can just use a different colored pencil, get a red colored pencil or something like that. Just make sure it's reasonably sharp and use a light touch, because those colored pencils tend to break a lot. So you can see here I'm lining up my protractor. Again, if you want, you can put the pencil in right in the middle. You can even look at the shadow. Line up the protractor, the pencil in the shadow, and make your mark. Right? Once you've got that, you're set for that one. You can either make your measurement with the protractor, or you can just move on to the next one and so on. Okay, so here we are. We've made our mark. Saw that. Now again, put my pencil back on the mark, because I want to go directly on top of it. I don't want to be off like that. I want it to be perfectly lined up. So when I lightly trace, you can see there I was a little off. So be gentle. You'll get better results. Generally, good way to live your life, in fact. So there's that. Just extended it there. If you go too far, it's not too far, it's fine. You just need enough to measure the angle. So I am ready to make my measurement. Again, there's a little bit of error because you're looking at the paper from an angle here, but looking straight down, the crosshair is directly on the vertex of this angle, right where the pencil mark and the dashed line meet. That's what we mean by vertex. The pointy part of the angle, if you prefer. Again, make sure this dashed line, when I'm looking straight down, passes along the 0 degree line, as well as this horizontal part of the crosshair. Oop. Again, 2 fingers hold it in place so it doesn't rotate. Now here you can see there's 40, there's 50, so this is going to be between 44 and 45. So I'm going to say that's 44.5 degrees. Now, to measure this one, if you can read the protractor upside down, great. If you can't, you can always turn it around. Again, crosshair on the vertex, that line goes, and by that line I mean the 0 degree line, goes directly over the dashed line. And if it looks like I'm a little off, again, it's because you're looking at an angle. Looking straight down, there's 40, there's 50. That's 45 degrees. Since it's right on the line, I put as 0.0, the degree mark. And you can see I did that one upside down, but really, it doesn't matter. Same thing for these other ones. Take this, put the mirror on. Now here, again, the important bit of the mirror to match is right up there, and we want to match the surface of the mirror right at the front edge of the line. The closer we are, the better things will go, but it's really easy to knock it off, so that's about as good as I can get. Now, this one's a little trickier simply because of the mirror. It's going to kind of sort of get in the way here. So, light on the ray, get it lined up. Okay, again, the ray of light is directly over the arrow. Now here, if you notice, this actually, because it's an inward curve, now I'm going to just barely tweak that. It actually, instead of widening, at first it narrows down, and then it starts to widen again. So we can be a little more precise with this simply because we don't have this wide. Now, notice we don't have a lot of room to move around here. If you get the light source too close to the mirror, you might not be able to get your protractor in there. If that happens, you can either move the light source back a little bit, or you can use a narrow or straight edge like a ruler or something like that. Again, here, my pencil lead, I check to make sure the mark is actually on the light before I finish, because the less I have to erase, the happier I am. I've made my mark, so now I can move this. And again, I'm looking to make sure, is the pencil line actually on the ray? It's maybe a little bit off. Instead of being perfectly on, it might be off a little bit like that, but it's really, really close. I'm happy with it. If I look in here, it's still roughly in the middle, so I'm going to call that a day. Now again, once we're here, you can go on and make your next measurement, or you can do this next little bit. So I'm going to put my pencil mark on, put my pencil lead on the existing mark. Now, hopefully you can see why we call this ray tracing. It's very literal. We're literally, and I mean literally, not figuratively literally. So I'm using the word literally, unironically, although some people might dare to say correctly. All right? So you can see the pencil mark traces out the path of the ray of light. That's the idea of ray tracing. Again, measure your angles, write them down. Life is good. Lather, rinse, repeat until you've got everything done. Once you've got all your drawings drawn, you're going to select one. I would select one that doesn't look too terribly messy, and maybe one that does not have one of the angles written upside down, but whatever floats your boat. You're going to cut it out. Now, you don't have to make sure you get every last millimeter of the pencil mark. You can trim it down to the essentials. You really don't want to go much smaller than something like this. Okay, but you do want to cut because you do want both of the angle measurements in there. And it would be really nice if you had the label on the